Hello everyone and welcome to the sky this month for June 2025. My name's Paul Martinaitis and this show is brought to you by the Astronomical Society of South Australia. So it's a great time of year to be observing as we're getting well into winter. The nights are starting nice and early. It's getting nice and dark early on. And also we can still enjoy some of the wonderful galaxies in constellations such as Virgo and Coma Berenices. As well, of course, is the fact that the centre of our own galaxy is coming into view very high in the sky. So we can look at some of the wonderful objects in constellations such as Sagittarius and Scorpius, as we'll see shortly. In terms of solar system viewing, this month will be a good month for observing the inner planets, Venus and Mercury, particularly towards the end of June. And also it'll be a good month for observing Saturn and Neptune as well. There's also, as a bonus, a lunar occultation of Antares, and that will be occurring on the 10th of June, and we'll talk a little bit more about that later on in the show. So as usual, we'll begin with a tour of the night sky. So we're looking at the night sky as it'll appear around the 15th of June at 9 p.m, so well after the end of astronomical twilight. So looking towards the west, firstly, we can see that the Argo-Navis constellations are now getting quite low. In particular, Puppis now begins the evening quite close to the horizon. Further up, however, we can see that the keel there, Carina, is still nice and high, and in particular the Eta Carina Nebula is still well worth a look at. And you may recall in the March show, or perhaps you missed the March show, during the Constellation of the Month section, I took a more detailed look at the Eta Carina Nebula and also some of the great objects around that, such as the Gem Cluster, the Pincushion Cluster, the Southern Pleiades, and so on. So if you missed that part of the show, I invite you to go back to the March sky this month and perhaps just take a look at the Constellation of the Month session. Further up, we can see Centaurus there. Centaurus is now really probably at its best viewing for the year, right near the zenith. So there's many fine galaxies in Centaurus, as well, of course, as one of the most famous globular clusters, Omega Centauri, or NGC 5131. That's also nice and high at the moment. And that's very easy to find, particularly under a dark sky. All you need to do is follow the pointers. So there's Alpha Centauri, Beta Centauri, and then you just follow this arc of stars along. So you go one, and then there's another star along here. So if you look at these two stars, they form the base of a triangle with Omega Centauri. And under a really dark sky, you can actually see Omega Centauri as a fairly faint fuzzy star. But otherwise, if you sweep that area with binoculars, you should sweep it up straight away. So a wonderful, easy to find object. Another fine object in Centaurus as well is the blue planetary, NGC 3918. That's also pretty easy to find. So that's a planetary nebula. The way I normally find it is just look at the beam of the Southern Cross. So start at beta, go to delta, and then if you move around the same distance again with your telescope or telrad, you should sweep up the blue planetary in your eyepiece. So the reason it's called the blue planetary is it looks pretty much like a very bright version of Neptune. So it's a fairly compact but really intense blue ball of light. And I find this is one planetary nebula where probably you don't need a filter to see it properly. A filter probably detracts from it. It's generally better to look at this one without a filter so that you can enjoy that lovely blue color. And while we're in this vicinity as well, long-term viewers of the show will be sick of me mentioning M83, but it is one of the finest southern galaxies, and in particular at the moment, it doesn't get better. It's really up high near the zenith. So if you're under a dark sky, do make sure to take a look at this wonderful galaxy. And in fact, I was privileged enough to look at it from the Flinders a couple of weeks ago, and it was truly stunning. Um, you couldn't see all of the detail as easily in this photo, of course, but I could definitely see with direct vision the core, a strong impression of this bar, and you could see these very faint lower arms along the bottom, as well as this irregular sweeping mottling on top. So it was a really wonderful sight. So if you're looking from a dark sky, I highly recommend you take a look at M83 through any size telescope. It's going to look great. Looking northward now, and we can see this, of course, is a region where there's a lot of great galaxies. So we can see Leo is already partially under the horizon at this time of the evening, but it's still not too late to have a last look at the so-called Leo triplet, which you'll find around this portion of Leo and some of the other galaxies along the top. Moving over to Coma. Some of the galaxies in there are also still well placed, particularly the ones towards the top of the constellation. Apologies there for that very loud and abrupt interruption there from Canis Major. He was asleep by my right there, and he got suddenly awoken, and he wasn't too happy about it. So just going above Coma, we of course have Virgo, and that's going to be the constellation of the month for June. There's Hydra, of course, the longest constellation. Part of it's at the moment below the horizon, snaking its way all the way up to near zenith. We also have Boots, and of course Ophiuchus towards the east. And down below here you can see Hercules. So not a bad time of the year to take a look at Hercules, in particular the globular cluster M13, which is one of, certainly from the Northern Hemisphere's point of view, probably their greatest globular cluster. But of course, in the south, we're privileged to have a number of arguably finer globulars, such as Omega Centauri, of course, 47 Tuc, and the Parvo globular. So finally, now turning towards more the southeast direction, just as before we're looking perpendicular to our galaxy, sort of looking out the plane of our galaxy to look at those more distant galaxies in Virgo and Leo and so on. As we're now looking in this southeasterly direction, we're of course at this time of year looking towards the center of our own galaxy, which is located here between Sagittarius and Scorpius. So the most dominant objects in this direction of the sky are these globular clusters, which you can see here on the screen represented by yellow dots. So a fantastic time of year to do essentially a globular cluster tour. You could spend all night just doing that. Just off the top of my head, a few of the fine ones that you won't want to miss are M22, which is very easy to locate here near the lid of the teapot in Sagittarius. In fact, I think Sagittarius has the most globular clusters of any constellation, and it certainly has the most messier objects as well from memory. And also another good globular cluster is M4, which is easy to find as well. It's right next to Antares, which is that red star, the brightest star in Scorpius. So if you put Antares, in a fairly wide field eyepiece in your telescope, you should be able to sweep up M4 quite nearby. And M4 is a wonderful globular cluster, and it's actually fairly unique. Most globular clusters are quite symmetrical, certainly in the center region at least. But M4 has this bar, this vertical bar that cuts across the center of it, which is kind of consists of a stream of brighter stars across the front. So make sure when you take a look at M4, take a look and see whether you can see that bar through the eyepiece. So now take a look at some of the key times for June. So now, of course, we're heading towards the winter solstice on the 20th of June, which will be the shortest day or the longest night, depending on how you want to look at it. Good time of year to observe because we can begin observing nice and early in the evening. We don't have to wait like in summer, till really late at night. So on the 1st of June, darkness began at around 1840 and went through to 5:48 in the morning. By the end of June, darkness will begin slightly later because we've passed the solstice at 1844, and it will go through to 5:54 in the morning. So the dark sky period, where the moon won't interfere with your deep sky observations, that'll begin on around the 18th of June and go through for 10 days through to around the 28th of June. The moon phases will be first quarter was on the 3rd, full moon will be on the 11th, last quarter will be on the 19th, and new moon will be on the 25th. So in the solar system, June and also particularly the later part of June and July is an excellent month or months to take a look at the inner planets. So we can see at the beginning of June, Mercury was in conjunction behind the Sun. But by the middle of June, by around, let's say, the 15th or so, it starts to become very well placed as an evening object. And particularly as June progresses, even into up to the middle of July, it's an excellent time to be viewing Mercury. So if we take a top-down look, you can see that its elongation from the Sun is nearly near its maximum. The orbit of Mercury is quite eccentric. So if we're looking at an elongation that occurs in this part of the orbit, of course, that's the least favourable because it never really appears far away from the Sun, so it gets caught in its glare. But when we can observe Mercury in this part of the orbit, its apparent distance from the Sun will be relatively large. So mid-June through to mid-July will be an excellent time to take a look at Mercury. And the same is true also of Venus, which is also at the moment large distance away from the Sun. Of course, it's on the other side, so that's going to be an early morning object. So the best time to view Venus will be just before dawn, just before the Sun comes up. So looking to the outer planets now, Mars is still quite visible in the evening. Really just a naked eye object now, I think. The distance between us and Mars is ever increasing, so it's getting smaller and smaller and also fainter. So the chance of seeing any detail now through a telescope is virtually nil, I think. Jupiter is currently in conjunction behind the Sun, so unobservable at present. Uranus, I think, is currently in Taurus, not too far from the Pleiades. You could perhaps just catch it before the sun rises in the morning sky, but I think at the moment not really worth pursuing. So that leaves us with two very fine planets indeed, and that of course is Saturn and Neptune. And you can kind of see here they're aligned in a straight line. So particularly if you haven't seen Neptune before, June and July are an excellent time to take a look at Neptune because the two planets are within, at the moment, I think they're within about 2 degrees of each other, but by the end of June and into July, Neptune and Saturn will be within a degree of each other from our point of view, really close in the sky. So basically, if you can find Saturn, which you can see with your naked eye, Neptune could very well be in the same field of view of your telescope. Certainly be in the same binocular field of view. And the other thing about Saturn, of course, at the moment, we're pretty much, the rings are very much edge on. I think they were exactly edge on during March when we couldn't observe it. They've opened up a little bit, and then later on in the year, they'll close up again a little bit as well. So now looking at the planets in the sky, we'll begin by looking at the early morning sky. So this is showing around the 15th of June at 5 a.m. in the morning, around an hour before the sun rises. So as we discussed before, excellent month to be looking at Venus. It reached elongation on the 1st, so that is its reached its largest apparent distance from the sun from our perspective. So it rises at the moment at around 3:30 a.m. in the morning, and it's visible, of course, until the sun comes up. And its diameter at the moment is a rather large 24 arc seconds, and it has a very bright at minus 4.4. So you just simply can't miss it when you look in the eastern direction. And also be sure to look out for its phase as well. So a little bit like the moon, Venus and also Mercury go through phases from a fairly full disk to half illumination, which we call a quarter, and it can also appear. They can also appear as a very thin crescent. So at the moment, Venus just coming off of greatest elongation, I think will show sort of roughly a half phase. So it'll look like a little miniature quarter moon. Higher up in the sky, between Pisces and Cetus, we can find Saturn and also Neptune very nearby. So Saturn is rising just a bit above past midnight, visible until the morning. Currently has an diameter of around 17 arc seconds and a magnitude of 1.1. Neptune is also very close by, and has a much smaller diameter, of course, of around 2.3 arc seconds and a magnitude of 7.9. So not really not at all a naked eye object, but under dark skies should be easy to pick up in a pair of binoculars by looking at Saturn, and certainly in a telescope it'll be readily visible. And while we're taking a look at Saturn, as we discussed in March, we went through the plane of the rings, so the rings appeared exactly edge on, but we couldn't look at Saturn at that time because of the sun. So the rings have opened up slightly, but we're still really in the plane of the moons, or the way they rotate. So you get interesting alignments like this, where the moons appear like a string of pearls coming away from Saturn. And in fact, this shows you the configuration of the brightest moons on the 15th at 5 a.m. And of course, different times they'll change positions. And at this time, when we're passing the plane of the rings, it is also possible to observe things like the same as we can see on the Jupiter moons, the Galilean moons, things like eclipses, transits and shadow transits, although they are much harder to observe with Saturn's moons because they're dimmer and smaller. But in the coming months, we'll discuss some of those events, and that can be a bit of an observing challenge for us. I haven't personally observed a shadow transit from any of Saturn's moons, so that's something that we can try a little bit later on in the year. So finally, this final slide here just shows you, like I was saying before, how close Saturn and Neptune are. So by the end of the month, Saturn and Neptune will be within a degree of each other. So this second red circle here from the Telrad is 2 degrees. So you can see there Saturn's in the center. So that's about 1 degree. So they should be visible, certainly in binoculars in the same field, but also within the wide field view of a telescope. So now we're looking from the morning sky. We're now looking in the evening. So this shows you the situation on the 27th at around 6 p.m. So, like we mentioned, excellent time to be looking at Mercury. So you'll find Mercury towards the west, just as the sun is setting. So you'll have a window between when the sun sets. The sky will start getting darker, so it'll be easy to see Mercury. But on the other hand, of course, the longer you wait, it'll get lower towards the horizon. So there's sort of a window there to get a good look at Mercury in the early evening. And in particular on the 27th, it'll be quite near a very slender crescent moon. So they'll make sort of a fine pair in the evening there towards the west. And finally, up high, just at the top of Leo, you'll find Mars. So that sets at around 10 p.m. Still reasonably bright at magnitude 1.4, but note that its size is now 5.2 arc seconds. So really small, too small to see any detail through a telescope. In fact, it's interesting to note that towards the end of June, Mercury actually swells to 6.8 arc seconds. So a Mercury will actually appear slightly larger in apparent size than Mars at the moment. And finally, as a little bonus this month, we have a lunar occultation, which is probably not something, occultations aren't something we've probably talked about in this show before. So some occultations, of course, occur when an asteroid passes in front of a star, which you'll generally need a telescope to look at. This is a lunar occultation. So this is when the moon passes in front of a star, which of course it does every night of the year. But it's not as common for the moon to move in front of a really bright star that's readily available to the naked eye. So this time, this is an occultation of Antares, which is the bright red star in Scorpio. So really easy to find. Now from Adelaide, so the event is predicted it's going to occur on the 10th of June, and the disappearance time is predicted to be 1855. So I would begin observing perhaps with binoculars, or even better if you can train a telescope onto it, or at least binoculars. Start looking maybe at 6:30 or 18:30, and then the moon should move closer and closer, and eventually, and it's approaching on the darker, unilluminated side of the moon, which will be pretty slender at the moment because the moon is still a fairly full phase. But nonetheless, there should be a slight unilluminated side of the moon, so you should be able to still see Antares, and then it will suddenly disappear as the moon passes in front of it. And then it's predicted to reappear at around 1954. So a little bit over an hour, a little bit less than an hour later. So our constellation for the month is Virgo. So our first object we're going to look at is Porrima, which is quite a famous double star for reasons we'll discuss shortly. So Porrima itself is quite easy to find. You can see here right up towards the zenith is Spica, which is quite a bright 0.9 magnitude 0.9 star. So we've got Spica up top, and you can see that forms a nice triangle with Arcturus in Boots, and you can imagine the base of the triangle over here goes to Denebula, which is at the tip of Leo. So if you go down the side of the triangle between Spica and Denebula, about almost halfway along, this star here is Porrima, the one we're after, also known as Gamma Virginis, and it's still pretty bright, very easy to see with the naked eye at a magnitude of 3.4. So two characteristics make Porrima quite special, in addition to the fact that it's a spectacular double to look at through the eyepiece. You can see there a simulated view. Both components have similar brightness, and at present, their separation is around 3.5 arc seconds. So that's a fairly easy split for most telescopes. And you can see their orientation is almost north, just a little bit less than dead north in this direction. So one of the things that makes Porrima special is the fact that it's one of these double stars. It's a physical system. The orbit itself is very well known, the characteristics of it. So it's quite eccentric. So at its closest approach, which last time was in 2005, you can see here the separation was really close. So this entire length here represents 5 arc seconds. So this distance here represents 1 arc second. So its closest separation was about 0.6 arc seconds, which is really tight and quite difficult to split. Even using a large telescope and high magnification required very steady seeing to actually achieve that split. But you can see as time goes on, the separation has rapidly increased. So another thing about Porrima is some double stars have an orbit in hundreds of years. The orbit is relatively brief, about 170 years or so. So in one lifetime, if you observe Porrima, you can see quite a bit of change in both position angle, the angle that the pair makes, and also in separation. So at the moment, we're at this part of the orbit here in 2025. So it's currently at around 3.7 arc seconds, and you can see there that it will continue to increase till around 2080, when it will be very large, probably in the order of 7 or 8 arc seconds, and then it will start to decrease again next century. So great double star to take a look at, and something you might like to do is maybe make a sketch of it, make a sketch of its orientation, and then if you did so every year, that would make an interesting project. And in 25 years or so, when we get to 2050, you should notice quite a change in the position angle, and the separation will be a lot further as well. So our next object now is at the very center of the Virgo supercluster, of which our Milky Way galaxy is a peripheral member, and that's M87. So to find the center of this cluster where M87 is very easy. So here we are where we left off at Porrima. So we're just going to move down the line of stars to this star over here in Virgo, which is Vinda Matrix, or Epsilon Virginis. And if we draw a line between Vinda Matrix and the nebula here at the end of Leo, about halfway along that line, you'll find M87. So you want to place, if you've got a Telrad or a red dot finder, you want to place it there about halfway along this line. And as we zoom in, if you look with a telescope, if you're under dark skies, you'll see sort of little clumps which represent the galaxies everywhere. But by far the brightest, a fuzzy bright ball of light, will be the supergiant elliptical galaxy M87. Now M87 is interesting for several reasons. One of the main reasons, I think, from my perspective, is you may recall a few years ago, the Event Horizon Telescope, which was a virtual telescope made up of various radio telescopes all around the world, took the first image ever of a black hole, or rather the accretion disk in the event horizon, which forms around the event horizon of the black hole. So what you're seeing here, this donut shape, that's the accretion disk, that material which swirls around the supermassive black hole as it's feeding on gas at the center of the galaxy. And I guess the event horizon would be somewhere, probably not exactly at that boundary where the dark region starts, but it would be approximately in that location. So that's where the actual event horizon of that black hole is. So when I look at M87 through the eyepiece, I sort of always have this picture in my mind and sort of think about that, you know, how fascinating it is to be looking in that region where one of the largest black holes known exists. And another point of interest is, like many of these supermassive black holes, when it's feeding on the gas is moving so quickly, really, really close to the speed of light, in fact, that it's actually emitting energy in X-ray wavelengths, and it shoots a bolt of plasma out perpendicular to the accretion disk. So that's this jet you can see here in this image taken through a professional telescope. So this jet can actually be seen through amateur-sized telescopes visually. There's been several credible reports, including one by the late Barbara Wilson, who was a very good visual observer, very reliable, through an 18-inch telescope. So I've tried for a number of years and still haven't successfully managed to observe it. But if you've got a reasonably large, let's say a 12-inch or larger telescope, if the seeing is exceptional and you're at a dark sky, it's always worth zooming in on the core of M87, maybe at 300 or 400 times, and seeing whether you can see the jet. If you do see it, it will appear as quite a faint little enhancement or spike, very short, nowhere near as long as you see in this image. It'll just be sort of in that region there, very small. And I think it's in a northerly sort of direction. So something to bear in mind when you're looking at M87. So, of course, in Virgo, there's so many wonderful galaxies to look at. We could spend a couple of shows just going through them all, and we'd just scratch the surface. But I just want to show you Macarian's chain as well. Some of you would be very familiar with this part of the sky. So we'll just here at M87. So if we move about a degree in this direction, you'll come across two other very large elliptical galaxies, M84 and M86, and they're at the start of a chain of galaxies called Macarian's chain. So I'll just zoom in a little bit and start at M84 and M86. I always forget the names of some of these other galaxies, so I've got a picture that I can see just as I go through. And this, in fact, is a picture from Wikipedia. So if you look up the one I'm referring to, so I'll just bring that over so that you can see it. So this picture here is on Wikipedia so if you look up Macarian's chain, and it's quite useful. So it starts at M84 and 83, and it just identifies the key galaxies. Under a dark sky, you'll see quite a number of other fainter galaxies around the place as well. Just remember that if you look at this photo, if you're looking for a reflecting telescope, generally speaking, the photo will be upside down for us. So I normally start at M84 or M86. This circle in here is half a degree. So you can see there that if you have a wide field eyepiece of, let's say, at least half a degree, but even better, about a degree, you're going to be fitting in a good number of these galaxies into the same field of view. So you'll also see these two elongated or thin galaxies there. So they're NGC 4402 and 4388. And then as you move along the chain, the next series of, I'll just turn those stars off, the next galaxies you'll see here are sometimes known as Macarian's eyes. So that's NGC 4435 and 4438. And then moving along the chain further still, you'll encounter another pair of slightly fainter galaxies. So that's NGC 4461 and 4458. We then move further down the chain to 4473. And then finally, the chain ends at 4479. So that's a great chain just at this time of year. Just scan along with your telescope, any size telescope with a nice wide field eyepiece, and just take it all in. It's just wonderful to see so many galaxies in such a small concentrated area of the sky. And once you've done that, what I would encourage you to do is then increase the magnification and then start studying some of the individual galaxies in the chain. Elliptical galaxies, you generally won't bring out any more detail, but take a look at some of these particularly elongated galaxies through the eyepiece, and you'll really start to see the shape of the halo. And in a larger sort of telescope as well, you may actually start to see, some of the structure in the galaxies as well. So in addition to the shape, keep your eye out for things like knots, which are brightening or stellaring in the halo. You may also see evidence of some mottling or even dark lanes. So it's always good when you're looking at galaxies to look at a variety of magnifications. Low magnification to take the overall environment of the galaxy in, but then higher magnification to try and bring out some of the details. Thank you for joining me in today's show. I really enjoyed producing it for you. I hope you found the information useful. And even though the nights at the moment are very cold, please do try and find the time to get out there when the night's not cloudy and view some of those wonderful galaxies and other objects that are available this time of year. So until the July show, clear skies and bye for now.